0. The curve passes through origin. Passes through. This is y equal to x mod x graph. Right. Can be written as can be written as can be can be written as can be written can be written as f of x equal to can be written as f of x equal to f of x equal to x square if x is greater than or equal to 0. X is greater than or equal to 0 minus x square if x is less than or equal to 0. X is less than or equal to 0. Therefore, f dash x, suppose f dash x, this can be written as f dash x, d by dx of x square is 2x if x is greater than or equal to 0 minus 2x if x is less than or equal to x is less than or equal to 0. X is less than or equal to 0. So, but f double dash x, f double dash x, double dash x does not exist, does not exist does not exist as f double dash f double dash 0 double dash 0 that equal to 4 f double dash 0 minus 0 minus 0 minus 0 minus that equal to minus 2 minus 2. Further f double dash x f double dash x equal to 2 if x is greater than 0 minus 2 if x is less than 0. X is less than 0. Thus f double dash x thus this f double dash changes sign at 0 changes sign at 0 changes sign at 0 and the tangent crosses the graph tangent crosses the graph crosses the graph crosses the graph at 0. At 0. Hence x equal to 0. Hence x equal to 0 is a point of inflection. A point of inflection or inflection. Inflection. Singular points. Discuss about singular points. For curve tracing purpose, singular points are most important. Singular points. Singular points. Singular points. Singular points. A category of points. A category points. A category of points on the curve. On the curve is called singular points. SP. Singular points. Singular. An equation. Equation. An equation. An equation. Y equal to f of x. Y equal to f of x. Determining a unique value of y. Determining a unique value of y. Unique value of y. Determine a unique value of y for given value of x. For given value of x. Given value of x. Given value. So for example, for example, f of x comma y. F of x comma y that equal to x square plus y square. Page number 245. Page 244. Minus r square. Minus r square. Minus r square. Minus r square. Then f of x comma y. F of x comma y equal to 0. That implies y equal to plus or minus under root of r square minus x square. R square minus x square. R square minus x. From diagram. A, B. This is figure one. Next, or y equal to root of r square minus x square. Like 0. A, B. Find that y equal to minus r square minus x square. A, B, 0, x, y. X square plus y square equal to r square. Equal to r square. So points A and B are common to the two branches. Points A and B common to the two branches. Two branches. Two branches. Putting differently. Putting differently. Putting differently. Putting differently. We can say that two branches of the circle. We can say and say. We can say two branches of circle. Branches. Two branches of circle. X square plus y square equal to r square. R square. X square plus y square equal to pass through points pass through point through points pass through points A and B. A and B. A and B. We have a generic name, singular point. We have a generic name Generic name, singular points. Singular points. Singular points. Have a generic name, singular points. So definition. 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 If k branches of curve, if k branches of curve pass through a point P, point P, point P on the curve, the curve on the curve f of x comma y equal to 0 and k greater than 1, k is greater than 1, then P is said to be P, said to be P is said to be P is said to be singular point, singular point or a multiple point or a multiple point, singular point or multiple point. Order k. Of order k. Okay. Singular points of order 2. Singular points of singular points of PTS means points of order 2. Order 2. Order 2. Known as double points. Known as double points, double points. BTS means double points. Thus, the points A and B, thus the points in figure, in figure, in figure A and B, A and B are double points. In figure 3, A and B are double points. Double points. Between double points. Obviously, a curve may have more than one tangent at the singular point, one corresponding to each branch, based on the whether tangent at double points are distinct, coincident, or imaginary. Double points are distinct, coincident, imaginary. We shall give special names such points. So whether tangents at double points, whether tangents whether the tangents at a double point, whether tangents at a double point double points, double points are distinct, are distinct, are distinct, coincident or imaginary, coincident or imaginary, imaginary, imaginary. So we shall give special names. So, special names. So, 1, 2, 3. Here, diagram 1. Yes. So diagram. Please. So why? Why? F of x equal to 0. F of x comma y that equal to 0. Of x comma. Second one, example. X, y. P1, P2, P3, P4, P2, P3, Gx comma y equal to 0, x comma y equal to 0. P1, P2, P3, P4, hx comma y. Here, definition a double point is known as a double point is known as known as known as a node. A node. If the two tangents at the point, the two tangents at the point, two tangents at the point are real and distinct. Are real and distinct. Distinct. Real and distinct. A double point is known as a cusp. Known as a cusp. Cusp. If two tangents are real and coincident, the if two tangents, page number 246, two tangents is equal to 246. If two tangents, if two tangents are real and coincident, real and coincident, real, real and coincident, coincident. Real and coincident. Real and coincident. Next, a double point is known as a conjugate. A double point is known as a conjugate. 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 Known as a conjugate. Conjugate. Are isolated. Are isolated. Are isolated. Are isolated. Are isolated. Isolated. Are isolated. Point if two tangents are imaginary. Isolated conjugate point. If the two tangents are imaginary, if the two tangents are if the two tangents are imaginary, imaginary, tangents are imaginary, tangents are imaginary, imaginary, tangents are imaginary. So above an example of each shown for f of x equal to x equal to 0, the origin is a node f of x equal to 0. Above diagrams, above diagram, above figures, f of x comma y, f of x comma y equal to 0 means that means first one, first diagram equal to 0, f of x equal to 0. So the origin is node. Origin is origin is node. Origin is node. For every gx comma y, p1, p2, p3 points are g of x comma y. Above figure 2. What is that? G of x comma y. G of x comma y equal to 0. The points, the points, the points p1 comma p2 comma p3 and p4 are cusps, are cusps, are cusps, are cusps. While point Q on curve, while 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 the point Q on the curve, the point Q on the curve, Q on the curve, Q on the curve, Q on the curve, hx comma y point UOINT. Point Q on the curve H x comma y equal to 0 is a conjugate point. Is a conjugate conjugate point. Conjugate point. Okay. Let us discuss one example. Example. So example. Take it as homework 46. Example. Example. 12.2.3. Take it as homework. Now we will discuss asymptotes. Most important. Asymptotes. A S Y M P T O T S. Asymptotes. A straight line is said to be an asymptote of the curve. A straight line. A straight line. A straight line. A straight line. Straight line. A straight line is said to be an asymptote. Is said to be an asymptote. Asymptote. Asymptote to a curve. To a curve. To a curve. If as a point moves, if as a point moves point moves plus or minus infinity. Plus or minus along the curve. Along the curve. Along the curve. The perpendicular distance of P. The perpendicular distance of P. Perpendicular distance of P. The perpendicular distance of P from the straight line tends to 0. From the straight line. From the straight line. Line. The straight line tends to a 0. Tends to a 0. Yes. CURVE. Curve. 0 tends to A. Tends to A. 0 ZERO. ZERO. From NCA 0 ZERO. 0. So consider the rectangular hyperbola. Example. 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 Consider the rectangular hyperbola. Consider rectangular hyperbola. Hyperbola. Rectangular. Hyperbola. Rectangular hyperbola. XY equal to C. XY equal to C. XY equal to C. That implies Y equal to C by X. C by X. Y equal to C by X. X tends to plus infinity. X tends to plus infinity. R minus infinity or minus infinity. Minus infinity. Y tends to 0. Y tends to 0. The mod Y is the distance of a point. Y is the distance 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 of a point P. Point P x comma y. Point P x comma y. X comma y. On the hyperbola. On the hyperbola. Hyperbola. The hyperbola. Page number 248. Yes, correct. Yeah. So diagram. Yeah, diagram. Asymptotes important for curve tracing. X, Y. asymptotes. These two are asymptotes. In single word, what is asymptote means? The curves do not touch us x-axis and y-axis uh, uh, till infinity. It will goes to till infinity. Such curves known as asymptotes. And then y equal to c by x equal to c by x. Your point px comma y x comma y are the relations. One more diagram. And 3, 2, 4. Yes. So this shows the x-axis is an asymptote of the curve. Here, let us x-axis as asymptote of the curve y equal to asymptote of 17 by 1 plus x square. 17 by 1 plus square. So y tends to as x tends to infinity or minus infinity. Again, this means distance of the point on the curve from x tends to 0 as x tends to infinity or plus infinity or minus infinity. X-axis is an asymptote of the curve. Is asymptote of the curve. This shows x-axis is asymptote of the curve. Asymptote of the curve. Asymptote of the curve. So, oblique asymptotes. Big asymptotes. Let y equal to example y equal to x plus 1 by x plus 1 by y. Oblique asymptotes. Oblique oblique asymptotes. Oblique. Oblique ascent. Example, 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 11.3.9, 11.3.9, and do it as homework. For 10 marks, this is important, 10 marks purpose. So we don't have time to discuss. So oblique asymptote. So you may be wondering whether an asymptote must always be parallel to the coordinate of axis. No, there are many curves having asymptotes which are not parallel to either axis. Such asymptotes are generally referred as oblique asymptotes. We shall now learn how to find oblique asymptotes from y equal to mx plus c. y equal to mx plus c equal to mx plus c. So perpendicular distance here. Suppose the y equal to mx plus oblique asymptote is 0. This means m is not equal to 0. Perpendicular distance from point to the curve. Perpendicular distance. Perpendicular distance. Perpendicular distance. Medium equal to y minus mx minus c whole divided by under root 1 plus m square. 1 plus m square. So our time is over. Do it as this is also dependent from this one and another 11.3.1. Both are important for theory 10 marks question. Okay. Okay. Thank you.